asteroids is being built. Let's take a look. This is the Fly-Eye telescope in production, which isn't what we usually picture a telescope to look like. Traditional telescopes have a narrow field of view, which makes hunting for threatening asteroids a slow and tedious process. But the Fly-Eye has 16 individual cameras, mimicking the structure of a fly's compound eye to offer an extra-wide field of view of 44 square degrees. With this field of view, the telescope will be able to detect asteroids at risk of hitting Earth in as little as a week in advance. So, how does it work? Lorenzo Cibin at OHB Italia gave us an up-close look at the machinery.
We can see here the full optical instrument connected to the ground support equipment, and then you can see here the central ring of the instrument that hosts such a lower part is the primary mirror. Kelsey, if you look there is a B-shaper that do a repartition of the field in 16 channels. This is, for example, one channel with the camera, CCD camera, and in this CCD project a portion of the sky.
An additional 3 telescopes are foreseen to be produced and placed in complementary locations around the globe to increase coverage and improve the efficiency of the network. Once this first Fly-Eye telescope is completed, it is destined for Mount Mufara on the Italian island of Sicily.
The telescope has to be mounted, has to be associated to an equatorial mount. The equatorial mount is a particular mount that allows to avoid that during the exposure time the stars track, and the stars in this way remain fixed in their position when we take a picture from the telescope.
And while the telescope is taking its pictures, it's important that the structure is very stiff in order to reduce vibrations that could blur the image and thus reduce the capability to detect very faint objects in the night sky. And remember that to learn more about space, about asteroids, or about the Fly-Eye telescope, you can visit our website at www.esa.int.
Thank you.